In this lecture, we are going to find a formula to determine how big my sample should be when I want to estimate the population mean. Let's look at this example. Lumber companies need to be able to estimate the amount of lumber that they can harvest from a tract of land to determine whether the effort will be profitable. Now, a company wants to estimate the mean diameter at breast height, which we call the DBH of trees. The company decides that they want to estimate the mean DBH to within 40 millimeters with 99% confidence. From previous studies in the same area, it's reasonable to assume that DBH of trees is normally distributed with a standard deviation of 180 millimeters. So we can rewrite the above information in the following way. The probability that the absolute difference between the sample mean and the population mean is less than 40 is equal to 0.99. We can also say the probability that the difference between x bar and mu, the sample mean and the population mean, lies between minus 40 and positive 40 is equal to 0.99. Now we can divide by the standard error throughout. So if we take this expression here and we divide by the standard error throughout, then we get this expression. And we also know that from the sampling distribution of the sample mean, we know that if we standardize x bar, then it follows the standard normal distribution. What we also know is if this is my standard normal distribution, from my Z tables, I know that the area to the left and the area to the right of negative 2.575 and positive 2.575. We know that those areas are 0.005. So the area in between must be equal to 0.99. And because of that, we can now say that this 40 over sigma divided by square root n is equal to 2.575. And from that, we can solve for n. And then the last thing that we need is to find a value for sigma. Now, from our example, we can substitute that sigma with 180 millimeters. And we get it from this information in our example. And if we substitute the 180 into our formula, we get for n more or less 135. Now, if you solve this equation here, you will get 134.27. And of course, n must be a whole number. And we always round up for n. We never round off, but we round up for the sample size. And now in general, we can say that to estimate the population mean with the level of confidence at 1 minus alpha, so that the error of estimation is less than a factor e, then the sample size required is given by the following expression here. It's Z alpha over 2, which we get from our normal tables, times sigma divided by E, and then we take the square of that expression. Now, for the population standard deviation sigma, what we usually do is we use information from previous studies to estimate that sigma, or we take a preliminary sample and use the sample standard deviation to estimate for sigma.